So in today's session, I'm going to talk about a little bit on pandas data frames, how pandas data frames could be used. So that's the plan for today, and let's start there. So we'll start with the Colab environment, creating a new notebook. Right. Uh, the first thing is we'll look at how we can create simple what we call series and then the data frames. First of all, let's load all the import libraries. So of course, we need pandas and we renamed as PD. And inside the pandas, we are using numpys as well. So therefore, I'm going to use numpy as well. So numpy as, so these are the two libraries to start with. Right. Okay, let's move to the next one. So let's look at how to create what we call series. It's like a vectors in, the NumPy. And when you have matrix form, we call data frames. Now, one of the issues, if you remember the NumPy array is we use numerical indexing, which is difficult when you work with the data sets. So therefore, in pandas data frames, you will see that we can directly, access the elements with the names, right? So we'll start with creating a series. For example, let me say S1 as my first series. The command is PD series. You are getting this now directly. Let me say 1, 2, 4, and 5. So I have 4 elements. And simply, I'm going to say print S1. Or you can just say S1. So once you do that, you will see you are getting a simple series we created. Okay, we have 4 elements and you can see you can have indexes as well. You can access each individual element by using the index as well, similar to what we have discussed earlier. Right. Now, if you check the shape of this, I hope you remember the getting shapes. Okay, maybe let me copy paste this code in the chat. Right. Okay, I'll move to the next one. Simply you can take the shape. We can say print s1 dot shape, similar to the shape command we have used with previously as well, which will give you have in just particular case we have just 4 elements, and then if you take the index, we'll list the elements. And it's interesting to see when you say index, it will say the format that we have used from the range function we discussed. I hope you remember when we use for loops, we use a range function. In similar fashion, it says the index start with 0, goes up to 4. So basically, you will have 4 elements, 0, 1, 2, 3, right? Not including 4. And then it says step 1. That's simply you are getting the shape and the index. Now, one thing that we need as I told you earlier, you can access element with index value. But the important one is here, I told you that has a disadvantage if you work with the data. For example, we can say 0 and we can see what happens. Right? So what we are trying to do here is instead of just trying to access it in the elements, we are going to use some index values. So therefore, instead of use of numerical index, so we can actually create with some index and you can have labels, right? But one thing is, if you want to access it here directly, you will notice that we will have getting an error. The reason for that is you have to use a method which you use the location. We can say index post. So in this particular case, if you want to access that, you can do. But then if you want access based on, let's say, the location, so then we can say ILOC as well. So this method we'll discuss, but this is not what we want to do. So what we really want to do is apply some labels for this. So therefore, we will provide with some index values. So I'm going to create a series with index values, right? And in this particular case, as you can see, you can notice it's automatically give me the code. I'm going to use this because it's exactly what I want to do. So we will notice that we can create it something like this. So now you can notice in previously we have numerical index. Now instead of that, we have labels, which is very easy for us, especially when we work with the data, right? Remembering the position of the data element will be difficult, and that's why we are giving some labels here. Right, so let me copy paste the code for you. So the difference from what we have discussed earlier, instead of numerical index, we are using labels here. Right. Now, once get like this, accessing will be directly this, right? So instead of just saying S to and 0, we can simply, for example, here, we can say simply S2A. You can access the individual values based on the labels that you provide. So this is called label based. Right? And if you want to have a position based, still it's possible. We'll discuss this later on, right? This is called position based, right? Both works, but especially why we learn pandas data frames is also like, yes, whenever you need to numerically access, you can use it, but then if you need labels, of course, it's possible. Right. Okay, now that we have looked at this, right, let's move to the next one. I hope you got the basic idea about creating a series, but very interesting part would be like creating data frames, right? Now for that, I'm actually need, data generation. So I told you like we discuss about the NumPy. I'm going to use NumPy to generate some data. So I hope you remember use of NumPy. In NumPy, remember generating some data. We use ones, zeros. Likewise, we use random values. So in random, we have rand end or rand and so on. So if you remember that, let's say I'm going to create a 3 by 3 random matrix. I hope you remember that we could use this command, right? Okay. Now, given this, let me create our first data frame. So let's create a data frame based on this. So let me use create a data frame. And let me say, I'm going to create my first data frame. I'm going to say data frame 1. dd dot the command is data frame. And I can simply use like this. Maybe this is our first one, and simply I will use the F. Right. If I run this, you can also observe that it's very nicely formatted in the Colab environment. Actually, if you click it this into interact, you can click convert this to interact table as well. But again, everything is in numerical indexes, right? In both the rows and columns. Right. Let's move on. So this is simply creating a simple, data frame and then just visualizing it. Like what we did um, for the series, we should normally use the labeling for this one as well. So we can actually use the same code with a little bit of improvement. So I'm going to get the same code here, copy paste to a new coding window. And the improvement I'm going to add here is I can define the columns, right? So ideally, if it is a data sets, we have some data. Let's say if it is, let's say about marks of some courses, for example, we can have course labels. So likewise here, I'm going to say column labels. Let me, for the time being, I will have simple labels like ABC here, right? So for the three. And you can observe the difference, which we will give A, B, C, and so on. Right. So I think we can move on. So in here, I actually just discuss simple labeling. Of course, if you want to have simple ABC, you can simply change this. That one also I will give you for the shorter representation of this. You don't have to actually separate out like this. Simply, you could have said list ABC. This is again the same code, but simply we have the labels ABC. Simply you can update the code simply like this, which will provide you the same data frame. Okay, there are many other ways that actually you can create data frames, but I think that you can explore more. So therefore, now let me discuss how we can actually uh, look at the basic information, right? So let's look at this. Now, for the very first command that I'm going to discuss is the getting the info. So info will give you about what this is, then the values, the columns, and their data types and so on. So simply whenever you create and when you want to get that particular piece of information, simply you can use the command use together with the print. We can say tf1.info. So when you run this, you will observe, right? So this will give you a little bit information about what this piece of information is. So it will say that it's a pandas data frame. The index, you have three elements going from 0 to 2. Data columns, three in total. And you can also notice each column, it will provide you some information together with their data type. even it lists uh, the usage as well. Right. Similar to this one, what we have discussed earlier could also be used. For example, um, you can use shape, which give you the shape of the data frame. So this will list the number of rows and number of columns. You can get the index similar to earlier. That information is also available. One more, if you need the column information, this is row information, right? We can say columns, which will give you the column information. And you can get some statistics if you want using describe, right? So after creating a data frame, you can use shape to get the number of rows and the columns. Individually, if you want to access the index details, you can say index, which will give you the row information. And if you want the column information, you can use columns. Okay, now that we have comfortable with this one, let me talk about the viewing a data frame. Now for that, I want to create a little bit a lengthy one. So I'm going to, do that. One more command. Um, so if you want to count how many values in each column, so you can say simply count as well. One. Okay. So the next part, as I told you earlier, I want to discuss viewing a data frame, especially when you load a data set. Let's say you want to access different parts of the data frame. So I'm going to discuss that next. Right. So let's move on to the next one. Let's create more rows here. So for the viewing, so how to view a data frame, that's what I want to discuss. So I'm going to create a new data frame. Let me say df2. Command, I hope you remember data frame, and I'm going to use random data. And for that, what I'm going to use is again the same thing, random. And then I will use rand end. So I'm going to say 100, 3. So this will create 100 by 3. And then let me use columns. Simply, I'm going to create a simple list. I will say A, B, C. So you know what will happen here. So if you just try to view, when you have data sets like this, you can notice that it won't show you everything you have, right? So usually in this particular case, you will see the first five columns and the last five columns. Sorry, first five rows and the last five rows when you're viewing it. So there are commands actually you can use to view the part of the data set. And that's exactly what I'm going to discuss next. So these are called getting the first few rows and first last few rows and so on. So we have commands like head and tail, right? Let me see. Okay, so now that we have finished up to this point, let's move to the next one. Okay, so when you want to view different parts of the data frame, there are a few commands actually you can use. So it's for df2. One is for head. So you can notice that this will give you first five rows. So it's called df2 head. Similarly, there's another command here. Will give you last five rows. Okay. So we can use head to get the first five rows, tail to get last five rows. Of course, you can change this if you want. Now, for example, let's say you know the first 10 rows, you can provide this as an parameter. So, for example, if you say df at 10, then that will give you, sorry, it should be df2 dot at 10 will give you the first 10 rows. Right. Hope you are fine with this. In case if you need something, just let me know in the chat. Right. With that said, let's move to the next part. Of course, this is what do you call it? A data frame. So that means it's in pandas. But of course, if you want to convert this, you can convert, right? So let me talk about this. Let's say the data frame we have, let's say we'll take the first five rows. And if you want to convert into a NumPy, so that can be done. So let me say uh, convert data frame to NumPy, right? So in time to time, if you want to use different functionalities, you may have to change that. That's possible. That's what I want to explain. So for example, let me say df3 equals the df2 dot head. So which will get the first 5 rows. And then let's say we want to convert it to NumPy. The simple method we have to use is to NumPy. So if you do that, what happens simply you get a data frame, df3, but it will convert it to NumPy. Right. The next one, if you want to convert this into a transpose, that also is simply what you can do. So if you say df3 dot capital T, which will give you the transpose, right? So right now we have 5 by 3, and simply you are getting 3 by 5. Okay. So simple working. Then actually you can get a lot of details about this statistics. Um, for example, using describe. So I'm going to use that next. Okay, next thing that I would like to discuss is about the use of describe method. For that, I'm going to use df2. We have 10 rows, sorry, 100 rows and then 3 columns. So describe can be used to get the information, and then this will give you information about what you have, right? Quick statistics can be taken from that. So we can say stats. So in our case, we had 100 data points. So you can see count is 100, 100, 100, and you are getting like mean values. So we are getting mean values. Standard deviation, minimum, max value. So all that information might be very useful when you're accessing data as a data frame. Right. So Vivi, I hope you are comfortable now. Right. Next, I would like to discuss how you may actually select. Vivi part we have done. We even discuss how you may actually convert it. Right. So the next thing that I would like to discuss is how to select rows, columns, the selection part. rows and columns. So basically, there are two commands I would like to explore with you. Right now, in a series, if you remember, if you just have just one row, you can just say taken one. For example, our previous data set. Let me talk about columns. Right. For example, we have df2. We can say getting A. You can use either single quotes or double quotes, which will give you a series. Why it is series? You are just taking one, right? But if you need like multiple values, then you have to provide within this as a list. You can comma separate them. So for example, the next one. So this will give you a series, just one. But if you want to get it as a data frame, right. Now the same thing you can do in another way. Simply you can use df2.a. Both are acceptable. Make a note of this because uh, when we talk about in the representation later on, we will use both techniques. So you should be familiar with both cases. You can use just df2 data frame.2. In our case, df2.a. That also the same as previous. Right. But if you need like multiple values, as I told you earlier, make sure that you use them. For example, in our case, let me say df2. Let me take the both the A and B, right? So in that way, you can make a list of columns that you want to keep. So in our case, actually, we have only just three. In any order, you can use just label to access this, right? So this is used in labels. Right. So the same thing can be done. Let's say we want to specify part of the data frame. The same thing, but if you want to specify both rows and the columns, what I mean by this, In this particular case, I'm going to use df.loc, and then we will say the number of rows that we are going to have. Just column, if you remember from the NumPy we discussed, we'll say everything, and then we'll say A comma B. So which list both A and B. So this is what, D, it should be DF2. You can notice it's everything, but of course we can say what we want to have here. I'll come to that point later on. For the time being, it will give you the same thing from the previous one, but accessing through the labels. So that's why we have used LOC here. Again, we access using labels. But this is very interesting whenever when you want to access, like, let's say, first 10 rows, then you can specify. Or let's say something in the middle, you can specify here. The same code, but if you want to use the position, right? You have to use I here. And instead of this, we can say 0 to 2. So when you say 0 to 2, it will be 0 and 1. First two columns. That's what it means. Not within the label, but we use just let the labels. So in this case, we use position, or we have used just the index. Right. So when you're accessing rows, you can use index here. So we are accessing the first one. Of course, you can use it. If you remember LOC, we can say 0, colon. We can specify both rows and columns. So both ways are possible. Okay, just create as a simple exercise, just create your own data frame and practice with columns and rows. Okay, so we have been discussing about accessing rows. So if you say df2.loc, we'll access just the first row. Similarly, if you want to have both rows and columns, you can say 0, and colon. So the whatever you type before the comma considered for rows and after that for the column. So basically you will use 0 here by index. So it will specify the first row, but all the columns. Right. Now we were here discussing the same thing. So if you say 0 to 100, this is the starting value, this is the stop. It goes from 0 to 99 because 100 is not included. So therefore it will display all 100 data points. So this is same as just the colon. So if you have start and end, you don't have to specify. If you just use colon, it's the same. Okay, let me explain this to access the first three rows. So the command is, we can simply say df2. Couple of ways you can directly say this, it's possible. So in this particular case, what happens? We are directly accessing the elements. 0 means the first column, first row, right? And then 1 and 2. That's what you are getting, right? So you will say 0, 1, 2. So first three rows. So in other words, you can simply, if it is the same, then you can just ignore the 0 here. Just we say colon 3. So this is another representation, which is the same one, right? So I'll copy this. Same results can be taken like this. There are a few ways that you can do the same. Of course, you can use df2.loc. This is also the same, right? There are multiple ways you can do the same. So please get familiar with this because different people use different notations and we should understand this. Okay, let me give you an example and tell me what happens there, right? Okay, what is the output of this? So this is same as df2 loc 50 to 56. Yes, can one of you tell me like the output of this? Starting value is 50. What it means? So this will say that it goes from 50 to 56, not including 56. So you will have 50, 51, 52, 53, 54, 55. Yes, goes from row number 50 to 55. When you say 56, that's the end value. It is not included. If you don't remember this, you have to, look at what we have done under the for loops range function. It's the same, start and stop. Starting value, you start with that value, goes up to the end value. Yes, exactly. So you should understand these representations. Yes, Parakrama's note is correct. When you say uh, 50 to 55, when you say it's an index. So the row numbers will be 51 to 56. You are correct, Parakrama, regarding that one because index start with 0. So when you say 50, it's actually a 51 row. You are correct. Right. Let me give you a little bit more complicated one. I know it's complicated, but I think you better understand this. So the LOC thing, it actually used with the labels. So actually we have indexes. So therefore, we can have a complex one like this. Um, something like something like this. Let me see whether you understand this. So for example, I can say df2 dot loc 50 to 56, comma. So you can understand this one, I hope. So df2.loc, this is using labels 50 to 56, that is goes from 50 to 56, comma, then we'll say A to C. We can say, okay, let me use this one as B. So that's why I said you need to practice a bit, see whether you can understand this. In this way, what we are trying to do is we are trying to manipulate different parts of the data. Sometimes when you have millions of records, you have to select part of the data and you should master these skills. Right. Now, this is labels. Same thing can be done. Now, good question, Hemal. Why we are getting 56? I told you this is using labels, right? Remember this. This is using labels, right? When you use label base, make a note of this. It's very important question that Hemal asked, right? It's not a slicing operation to say that it goes from 50 to 56. Same thing if you do it LOC, you will see the difference. Let me show you that one as well together with this. So if you say ILOC, right, then we are using the slicing operation. So in this particular case, let me put the same thing, 50 to 56. This might be asking. And I will put 0 to 2. This is position base. Good question actually here, Malas. This is position base. So in this particular case, you will notice it goes up to 55 because it's position. And this is what we have discussed in the slicing operation, goes up to 55. And this is different. This is label base. When you use label base, it will include everything. You got the two different ones, right? So Hemal, I hope now you understand. So it is because of the previous one uses labels. And the second one where we use the index values, the positions we consider in the numerical ones. Okay. My suggestion is you spend some time figuring out how exactly this will work, right? Okay. The next one, if you want to access individual elements, how do you do that, right? So, for example, let me use head. So this will give you our first 5 rows, right? That you already understands. Okay. Let's say I want to access this element where the row index is 2, right? And the column index is 0, right? So we can use the same thing that we have used earlier as well, ef2 dot iloc based on the location. I can say 2 comma 0. So when you say 2 comma 0, it's a position based. You can notice that it will access this element, right? This value. So there's another command that we can use if you're just using just single values. We can say I at, right? We can say 2 comma 0. So normally this is known as a very fast way of accessing if you're accessing a just individual element. So make a note of that one as well. 2 techniques. Right. We were discussing about accessing columns, rows, and then individual elements as well. So I hope now you are comfortable with accessing elements, column level, row level, and so on. Right. Now, let's see how we can filter data. Now, sometimes we want to see what elements we have. So simple filtering we discussed. This is actually we have discussed uh, under the NumPy as well. Uh, what exactly happens here, filtering means simply we can check what values we have, right? Now, for example, let me take our DF2, right? If you look at our DF2, you can see there are positive values and there are negative values, right? So let's say I want to filter out all the data points where column A is greater than 0. So what I can do is I can say A, then I can say, okay, the value is greater than 0. Right now, if you do this in this fashion, what you notice is you are getting true false values, right? If you just use this, you are getting true false. That will indicate whether this is true or not, right? But if you want to, select the data where A is greater than 0, this is how we will write. So we will say df2. This is normally called a mask, right? So if you do that, you will notice now all the values in A now positive values. Can you notice all values in A positive values? So simply we can say select all rows where the values in A is greater than 0. So that's what we did here, right? So this is sometimes very useful whenever you want to access or filter values. Okay, the filtering part is also, I think, you understood. So in previous one, we look at the values where in column A, if it is greater than 1, we select it. So instead of saying DFA0, we can write down a different one. So for example, I can say DF2. Whether every value is greater than 0, you can notice what will happen. This is slightly different from the previous one. So if you put it that way, you will see you are getting true, false value based on whether the values are greater than or equal to 0. So if you are just selecting them, like in previous DF2, and then if you put it like this, it's slightly different. What happens if the values are greater than 0, it will keep as it is. Whatever the values are not greater than 0, will replace with nen. Nen is a special value, not a number, right? So that's what we observe here. So if the values are greater than 0, we keep it. Otherwise, we replace it nen. So that's what it means. So in previously, what has happened? We have filter out. Everything will be removed, but in this particular case, you will notice that it will not remove. So that's slightly different. Different in filtering. Okay, next part I'm going to talk about sorting. Right? And how do you rank? So this is also useful when you're working. So let's look at how to sort. Sorting. Simply, when you want to sort, you can use the index value. So one command we can do is something like this. So there are two commands we can use: index. So sort index means like based on the index you sort it, there's no change. But you can change the other way around. We can say ascending and we'll say false. What has happened now? Now let's observe. So the last index will come to the top. So in this command, what you notice is how to sort the data. We have used index to sort it and we say ascending false. What happens? Then it's sorted in ascending order. Now, if you look at the help, you will get more information about this. So I'm going to take help. DF2, let me see, sort index, we'll give that. Let me see. Okay, you can notice here, sort index. It says axis is 0, right? And then you can see other information ascending is also here. So why I actually said if you want to, sort based on the columns, then you have to change this. Let me give you the command first. First of all, let me share this in the chat. Right. It came to very top. I don't know how. Okay, so this is what I have. Right. What I want to say here is there's something called axis. Now, when you see axis 0, it's rows. Axis 1 is column. So I'm going to say axis 1. So what happens here? It's try to sort based on the axis 1 means the columns. So it's same A, B, C. Now I'm going to say ascending false. So when you say ascending false, you will notice it comes as CBA. So basically what happens in this particular case, we are sorting the columns in ascending order. Right. That's a use of sort index. That is using sort index. There's another one. It's called sort values. So let me share that next. So if I take df2 sort values, okay, this is based on the values. By, I will say B. Okay, what exactly this means? This will sort, I will show you the answer. This will sort the values in ascending order based on the column B. So you can notice the lowest value here, B minus 2.7, maximum is 2.5 something. So in this command, it will sort all the values based on the column B in ascending orders. Right. Have we finished up to this point? So in this particular case, the values are sorted based on the column B. Next one. Now, given a data set, let's say these are accuracies and you want to find the rank, the label ranks based on the values. So that can be done. We can say df2.rank will rank all the values. You might not understand right now what this means, but we already know the rank can go from 0 to 99, and that's what exactly you will see here. So it will rank starting from low value to the highest value. Done. Let's move on to the next one. Now, assuming that some data, what I can do is I'm going to use the same data set just to show you like how to handle the missing data. Missing in the sense you remember that the values that we have checked, right? For example, I can say, okay, df2, whether they are greater than 0. So if that is the case, I told you, it will show you whether it's true or false. So that is there, right? So let me take like this. So I'm going to say df, let's say 4 equals df2, df2 greater than 0. Right now, if you remember what we have done, this I have already showed to you. The values which are greater than which are greater than 0 will be displayed. Others display as a not a number, right? So what we can do is we can drop all the values. So for example, now here we have, let me share this with you. And the next one which I want to show you is, let me say it's df5. I'm going to say df4 drop na how equal na. So let's observe the outcome. You can see what has happened. So you can see only just few rows without any. So what has happened? If there are any values, right? Na values, we have removed them. And this is what we are getting. So if you are removing in that way, this is one technique. What is the one technique? We have considered all the value which are greater than 0 and we have dropped Na so that we get data without any missing values. That's one way. The other way is, let me say like this, df, that is 4, right? This is df4. What is df4? We have nans. Those not a number thing we can fill in, and we can provide a value. So let me say it's 0. So if you do that, what happens? All the NaN values will be replaced with 0. So these are some pre-processing techniques we can use. If the values are not greater than 0, we can decide how to handle this. Okay, so now let's look at some aggregation values. So I'm going to talk about aggregations. First of all, getting means. So in DF3, we have 100 points. Yes, we have. That's DF2, right? In DF2, we had 100 points. So I'm going to go with this one. So the first command is a mean value dot mean, which will give you a mean value. So the average values in each of the columns. Right? We can say column means. Similarly, we can have row means as well. So same command df2 dot mean, but if you say axis, I mentioned this earlier as well, right? What happens? You are getting row means. What do you mean by row means? Each row, you find the row. We have 100. So these are the mean values over the rows. So we find out column means and row means. Right. So aggregation, I mentioned about calculating means. Here we calculate the mean values to row wise and the column wise. Now let's say we want to calculate columns and means for A and median of B. So there's a way that we can do it. This is a little bit advanced one, but I hope you can try to understand this. So I'm going to say df2 dot method that I'm going to use aggregations. These are called aggregation, aggregate, and then we have to provide some functions for this. For example, we can use sum, we can use min, and so on. Right, now I'm going to actually use both. Um, so instead of saying this, I will say A. Okay, what I'm trying to do is I will put this and I will say A, and then and A, we let's say we need both mean and standard deviation. Mean and STD, standard deviations. Right? That's one. And then for B, let's say we need, these are like function names actually we are going to use. We'll say median. So basically what this query means, we are asking to calculate the mean and standard deviation for the column A and median for the column B, right? So we have mean and median for the column mean, standard deviation. This is median. Right. Another example. This is a little bit advanced one. Make a note of this. Use of advanced queries. Another one, quantile values. So for example, let me take another one. One last one for today. Okay, so the command is something like this. I can say df2 dot a. I hope you remember what happens here, right? In this case, we are getting a only. And dot, I will say quantile. So basically, I will say what we want to have. So 0 points, that means 5%. We'll say 50% and then 95%. So that we can actually get like this. Okay, so that's all for today then.